Welcome back, students. In this lecture, we will continue the second part of case study, that is Google Cloud Platform. This video lecture duly focused on Google Cloud Platform services and what Google is offering, and in the end we will do one practical or live demo to understand the Google service. This platform includes a range of hosted services for compute, storage, and application development that run on Google hardware, and it can be accessed by software developers, cloud administrators, and other enterprise IT professionals over the public internet or through a dedicated network connection. Talking about services offered by Google is a big list that include compute, storage, networking, big data, machine learning, and Internet of Things. Google Platform also provide cloud management, security, that is very important, and developer tools, where the top cloud computing product in GCP includes Google Compute Engine, Google App Engine, Google Cloud Storage, Google Container Engine, where the Google Compute Engine is a infrastructure as a service which provide virtual machine instances for workload hosting. Similarly, Google App Engine, which is a platform as a service, and it gives software developer access to Google's scalable hosting, which include SDK, that is software developer kit to develop software, and that runs on App Engine. So students, it is well defined that Google Cloud Platform is a set of services that enables developers to build, test, and deploy application on Google's reliable infrastructure. That's why it is a suite of public cloud computing services offered by Google. Students, even Apple uses Google Cloud Platform for data storage for its iCloud services. And most recently, GitLab and Tutor moved to Google Cloud. So it's better to say that Google Cloud Platform is a set of modular cloud-based services that allow you to create anything from simple website to complex applications. Talking about Google Cloud Platform services, it primarily focused on to provide a platform to build application, to store application, that is to store data using cloud storage, and then to analyze using some kind of query servers or services to meet the requirement of customers. As we had said in our previous slide, that it is a set of modular cloud services that allow you to create anything from simple website to complex application. GCP for compute include cloud services such as App Engine, which is a platform as a service, and cloud computing platform for developing and hosting web application in Google managed data center. Whereas Google Compute Engine is an infrastructure as a service offering allow client to run workload on Google physical hardware. Basically, it allows customer to use virtual machine in cloud as server instead of acquiring and managing server hardwares. Google Compute Engine is the infrastructure as a service component of Google Cloud Platform, which is built on the global infrastructure that run Google search engine, Gmail, YouTube's, and other services. Talking about storage, it provides a large variety of storage to the customer depending upon the Google storage plan. By default, all Google accounts include 15 GB of storage for free. Google SQL is a fully managed database service that makes it easy to set up, maintain, manage your relation database on Google Cloud Platform. We can use Cloud SQL with MySQL, PostgreSQL, or SQL Server. On the other hand, Google Cloud Platform Cloud Database is a highly scalable, fully managed non-SQL database service offered by Google on the Google Cloud Platform, where data store is built upon big tables and megastore technology. Talking about services, where Bigquery is a kind of data warehouse on RESTful web server that enable scalable, cost-effective, and fast analysis of big data working in with cloud storage. To understand Google BigQuery in more detail, I am showing you this small video.
With big data, we've come to expect big responsibility. In order to handle the complexity of today's data, you need to spend a lot on hardware, plan ahead for scalability, and pour hours into system architecture. It's no joke. And this just gets you up and running. You still need someone, no, a team, to make sure everything's running smoothly. And even after all that headache, running queries can cost. Wouldn't you rather focus on finding insights from your data than developing the infrastructure around it? Google BigQuery is a fully managed data warehouse that removes setup hassles and runs queries rocket fast. Fast enough to analyze terabytes of data in seconds, petabytes in minutes. Google BigQuery works on a pay-as-you-go basis. You only pay for the bytes processed. What if you have a really big query? It's simple. We'll spin up an entire data center to quickly process it for you. Just sit back and let us handle the scaling. Google BigQuery encrypts, replicates, and deploys your data across multiple data centers for maximum durability and service uptime. With just a couple of clicks, you can control where you store your data. Sharing and collaboration are easy as well. You decide who can access your data. And because you can use standard SQL queries, anyone can get involved. Plus, BigQuery integrates with Google Cloud Platform products and other software, so you can readily load, process, and make interactive visualizations of your data. It's never been easier to analyze massive data sets and find insights fast with Google BigQuery. Head to cloud.google.com/BigQuery.
I hope this video have given you some idea about BigQuery. On the other hand, if we talk about Cloud Endpoint, it is a distributed API management system. It provides an API console, hosting, logging, monitoring, and other features to help you create, share, maintain, secure your API. Students, I hope now you have some idea of Google Cloud Platform services. I hope now you can answer this question that why to use Google Cloud Platform. Since it supports big infrastructure, first of all, as we have discussed in our previous slide, like YouTube, Gmail, Twitter, and even the Apple is using Google Platform services. As you can see, that's 425 millions user they are using Gmail account. So it has attached with very large number of consumers. It provides integrated search engine web pages that contain the keyword you use to search. To search web pages, Google search engine use PageRank, an algorithm which is used by Google search to rank web pages in their search engine result. It is basically a way of measuring the importance of web pages. This is the only search engine with 92.6 market share and handling more than 5.4 billion search every day. With this animation, students, you will learn how Google search engine works. So every time you search, there are thousands, sometimes millions of web pages with helpful information. How Google figure out which results to show start long before you even type, and is guided by a commitment to you to provide the best information. So let's check it out.
Every day, billions of people come here with questions about all kinds of things. Sometimes we even get questions about Google search itself, like how this whole thing actually works. And while this is a subject entire books have been written about, there's a good chance you're in the market for something a little more concise. So let's say it's getting close to dinner and you want a recipe for lasagna. You've probably seen this before, but let's go a little deeper. Since the beginning, back when the homepage looked like this, Google has been continuously mapping the web, hundreds of billions of pages, to create something called an index. Think of it as the giant library we look through whenever you do a search for lasagna or anything else. Now, the word lasagna shows up a lot on the web. Pages about the history of lasagna, articles by scientists whose last name happened to be lasagna, stuff other people might be looking for. But if you're hungry, randomly clicking through millions of links is no fun. This is where Google's ranking algorithms come into play. First, they try to understand what you're looking for, so they can be helpful even if you don't know exactly the right words to use or if your spelling is a little off. Then they sift through millions of possible matches in the index and automatically assemble a page that tries to put the most relevant information up top for you to choose from. Okay, now we have some results. But how did the algorithms actually decide what made it onto the first page? There are hundreds of factors that go into ranking search results, so let's talk about a few of them. You may already know that pages containing the words you search for are more likely to end up at the top. No surprise there. But the location of those words, like in the page's title or in an image's caption, those are factors too. There's a lot more to ranking than just words. Back when Google got started, we looked at how pages linked to each other to better understand what pages were about and how important and trustworthy they seemed. Today, linking is still an important factor. Another factor is location, where a search happens. Because if you happen to be in Ormea, Italy, you might be looking for information about their annual lasagna festival. But if you're in Omaha, Nebraska, you probably aren't. When a web page was uploaded is an important factor too. Pages published more recently often have more accurate information, especially in the case of a rapidly developing news story. Of course, not every site on the web is trying to be helpful. Just like with robocalls on your phone or spam in your email, there are a lot of sites that only exist to scam, and every day scammers upload millions more of them. So just because instantvirusdownload.net lists the words lasagna recipe 400 times, that doesn't mean it's going to help you make dinner. We spend a lot of time trying to stay one step ahead of tricks like these, making sure our algorithms can recognize scam sites and flag them before they make it to your search results page. So let's review. Billions of times a day, whenever someone searches for lasagna, or resume writing tips, or how to swaddle a baby, or anything else, Google's software locates all the potentially relevant results on the web, removes all the spam, and ranks them based on hundreds of factors like keywords, links, location, and freshness. Okay, good time to take a breath. This last part is about how we make changes to search, and it's important. Since 1998, when Google went online, people seem to have found our results pretty helpful. But the web is always changing, and people are always searching for new things. In fact, 1 in every 7 searches is for something that's never been typed into the search box before, by anyone, ever. So we're always working on updates to search, thousands every year. Which brings up a big question. How do we decide whether a change is making search more helpful? Well, one of the ways we evaluate potential updates to search is by asking people like you. Every day, thousands of search quality raters look at samples of search results side by side, then give feedback about the relevance and reliability of the information. To make sure those evaluations are consistent, the raters follow a list of search quality evaluator guidelines. Think of them as our publicly available guide to what makes a good result good. Oh, and one last thing to remember. We use responses from raters to evaluate changes, but they don't directly impact how search results are ranked. So there you have it. Every time you click search, our algorithms are analyzing the meaning of the words in your search, matching them to the content on the web, understanding what content is most likely to be helpful and reliable, and then automatically putting it all together in a neatly organized page designed to get you the info you need. All in, 0.81 seconds? Wow. Anyone else ready for dinner? Interested in learning more? We've got a whole website dedicated to how search works. Just click right here. Want to read the search quality rater guidelines for yourself? Click right here.
That's how the Google search engine works. Another reason why Google Cloud platform is used that it serves billion hours of YouTube, and also it's global, redundancy and innovative.